So any thoughts from anybody there? The growing speed, yep, an evolution of technology, scarily so, isn't it? Thanks, Chitty. You can just think about what you think we're currently dealing with. Distributed of teams. I love it. I'm glad someone else does that. So yes, that we're dealing with teams that are distributed. We're dealing with large-scale projects and requiring a lot of collaborative work. And there's some of the issues that I'm going to be touching upon as well, I hope. I also want to just talk about what I think some of the technologies are. Yeah, the non-functional requirements. Yeah, excellent. And I'm going to give 3 broad exemplars. And the first exemplar is illustrating that we can have software, but just having the software isn't enough to make it used, which can sort of go to the non-functional requirements. So coming from a clinical background, I do a lot of work in the health IT space. So I just want to pick on telemedicine as an example. And this infographic would suggest 1924. It's been going on since. And I think a lot of the key, more off-the-shelf available technologies have been available since the 1990s. And indeed, we were involved in a telemedicine project in Australia back in the 1990s, connecting intensive care units together. So the technology exists, the software exists, yet last year in the US and in Australia, the figures that I've seen, only about 1.1% of consultations took place over video conferencing, making use of telemedicine facilities. Now, clearly, COVID has changed that. And I love this headline in the newspaper that talks about, it being a game changer for patients. It's been there as a potential game changer for patients forever, but it needed a pandemic to really get it into use. And we could think about e-learning as well, and the way in which we've moved a lot of our learning online. And also, interestingly, this newspaper article, and it reflects the research, talks about steep learning curve for many doctors. So, we have seen an increase in telemedicine, telehealth consultations, and I don't know whether it will stay at these sort of figures. Again, this is a figure from a US study. As an Australian study I've seen is fairly similar, but I think it's going to be different. So the software's been there, but it's taken a long time to get it into use because of all of the cultural, financial, professional, legal, medico-legal, regulatory aspects, I think, and just professional practices that are barriers. My second exemplar is also from the health IT space. So if I were to ask you to think about when do you think that the first electronic records were developed, just give yourself put a ballpark figure in your head, I don't know, some decade. And would you have said 1960s? In fact, the work on this would have been taking place in the 1950s because this was an actual live system in a hospital. And since that time, there'd been a lot of work going on in electronic records where institutions were doing it or companies were doing it. And then in the late 90s, early 2000s, many countries started to develop more national infrastructures for electronic health records. Yet despite enormous sums of money being spent, these are the sorts of headlines that we see. Some 10, 15, 20 years later in Australia, in the US, in the UK, and even in Norway, where you're currently looking at moving to the EPIC system, a recent journal paper that talks about issues. And this exemplar points to the fact that developing good software that actually works in practice is really hard in this very complex environment. And it also has very hidden human costs. So many research studies point to increasing burnout amongst physicians and nurses and other clinicians, even before COVID, that have been linked to, in large part, to electronic record systems and being hard to use and creating extra work. And then, of course, we can pick up on some of the new technologies that we have, that we're seeing now, the more emerging technologies. And I see a comment up here about ethics of software developers regarding privacy and military robots. So we're seeing a whole other range of issues when we look at, the Internet of Things, people being able, airplanes being too complex to fly, social media becoming implicated in democratic processes and election outcomes, biased algorithms being used for algorithmic justice or injustice in sentencing recommendations and so on. And the concern about robots taking people's jobs and automation. And Adam Greenfield has a really nice quote that just says, God forbid that anyone stop to ask what harm all these technologies might do. And you could all think of your own examples in this sort of space, because there's a lot of talk in the media and in the research space around these. But what this set of examples points to is the way software now is becoming increasingly entangled in all aspects of everyday life, of politics, of society, of education, of health, of fundamentally being human. And this is huge. This is really huge. Way back in 1986, a technology professor of history, or a professor of technology history, talked about technology's interactions with environmental, social and human consequences, and having different results, and the technology not being good or bad, nor is it neutral. And if that was the case in 1986, how much even more so now, where we have in really constantly changing, unpredictable landscapes, and brought to the fore even more so by a COVID situation of the last year or so, where we're dealing with wicked problems where there's no right or wrong answer, and where you can never understand that, all of the requirements up front, and we're dealing with really complex systems. And because they're complex systems, there are often unknowable requirements, and yet the technologies can have big, unanticipatable consequences, as many of the headlines that we might see in newspapers point out. And again, as reflected in some of the comments in the chat, it is needing increasingly diverse, large collaborations and teams, and engaging with very different sorts of stakeholders, and taking a concern from multiple levels. So it's, we have to think about, if we take the healthcare space, the doctor interacting with the patient at the point of care, but we also need to take care of the organisational concerns and the government's regulatory concerns, and maybe the epidemiological concerns, and so on. And we're needing to bring in increasingly diverse disciplines to solve these problems, to address these challenges. Technologists on their own are no longer able to do it. And that means we really need to admit we don't know stuff, and that we need to work together. We have a huge contribution to make, but we're not going to know what the solution is or be that confident about it. And we've got to work out how to work together, and we've got to accept that we're going to learn by doing and reflecting and iterating, or not, because that needs particular processes and mindsets. And in a conversation I had with Moshe Vardi for the podcast a couple of years ago, a quote from him, he talked about, like Ender from OS Card's Ender's Game, a sci-fi novel, we realised recently that computing is not a game, it is real. And it brings with it societal benefits, but it also has significant societal costs. And he says, suddenly we, meaning us software engineers, computer scientists, technologists, are running society, and we are poorly equipped. We are poorly equipped. So I want to ask, what might equipping look like? And equipping for practitioners, researchers, our students. And what have we done so far in equipping in response to the challenges that have been around? And it's really encouraging to see that we're getting increased initiatives from our professional organisations to update and develop codes of ethics, codes of professional practice. We're seeing lots of initiatives like in Vienna, we have the Vienna Manifesto on Digital Humanism that is based on the very principle that these are big societal technologies implicated in big societal challenges, and that we need multiple disciplines working together. And you'll find various manifestos around the place, and there are also people who are calling for a Hippocratic oath of for technologists, for technology. And we're also seeing that sensitivity understanding in many of our funding calls from funding bodies, where they're actually looking for interdisciplinary collaborations and slowly breaking out of our disciplinary silos for funding and research. We're seeing increasing concern for issues around values in computing. And Maria Angela Ferraro, who I saw on one of the organising committee slides, and John Middle and many others, we've been involved in running a workshop at the CHI conference looking at values in computing that came up with a Denver manifesto there that you can sign, and a Dagstuhl seminar also looking at these issues. And there are other colleagues like Batya Friedman and David Hendry at University of Washington who've been doing enormous work over the years in value-sensitive design and have developed these really useful toolkits and other creative works, as well as exercises for classrooms to help think about and work with values in technology design. We're also seeing an increasing turn to ethics and really taking the ethics of technology seriously. And Casey Fiesler has an open spreadsheet document here where people can share their different courses that they're offering around ethics and technology. And at the moment, there are 290 courses listed there, which is really encouraging. And Casey also shares some resources that she uses in her own teaching, working on Black Mirror scenarios. Black Mirror was a futuristic TV show, if you aren't familiar with it, and using those sorts of Black Mirror scenarios to get students to speculate about what some of the technological ethical implications might be. And my own colleagues in my own human-computer interaction group, Christopher Fraunberger and Peter Pergethofer, have developed a new course called Ways of Thinking that they offer to our first years. So this course was replacing the Basics of HCI course that we used to offer for first years, which was a much more practical, functional course about how doing user-centered design and some of those sort of more basic HCI concepts. And we realized that actually we needed students to come in from the very beginning of their degrees being far more critical and questioning about the technologies that they were designing, the software they were building. And so you can see in this course, they get the students to explore very different modes of thinking, from what you might expect about computational thinking and mathematical thinking, to design thinking and to critical thinking and even to criminal thinking. And Amy Coe also wrote a very good article not so long ago in the communications of the ACM, also calling for a more critical turn in computer science education. And I think these are all brilliant initiatives and really important and really timely. But my proposition is that still good software and good software engineering and technical skills and whatever disciplinary skills we might bring to these collaborations, good ethical guidelines in that, and even recognizing the need for multiple disciplines, all these are really good and they're necessary, but they're not yet sufficient. And I think there's an elephant in the room that we miss in all of this, because a lot of those things around guidelines and using design cards, while they're good, they're the what's. They put the emphasis on almost this disembodied view of ethics and design and whatever. But they're not disembodied processes, because there are human beings who carry them out. It's us. And we often don't get mentioned in these discussions. in the details of us thinking about how do we, as the researchers, educators, students, policymakers, whoever, recognizing that we're the ones who very practically need to operationalize what's in those ethics guidelines, what's in those value cards, that we're the ones who need to practically engage at multiple levels of scale and engaging with domains that we may not know anything much about. That we're the ones who'll need to work out how to work together as we saw in the comments in the chat here, that we're the ones who are going to need to work out how to work together in these distributed development teams, or in these increasingly diverse, in terms of disciplinary perspectives, teams. And we're the ones who need to be able to deal with the fact that we've got these uncertain, complex environment where it's going to be uncomfortable not knowing all the answers, and where we're going to need to be adaptable in very practical ways as we accept that we need to make mistakes and learn and iterate, often with societal consequences. This is all human level work. And I think it points to the who and the how those previous whats get done. They point to the work to make those things work in our projects day to day, moment to moment. And it's fundamentally a human problem. And a quote, and I'm really sorry whoever said this because I've lost the source, but I still wanted to use it because I like the way they talk about, although the focus is on technology and technical solutions, because that's what we're about. A broader base of competences and perspectives are vital in order to find solutions to the complex challenges of today that technology is entangled, implicated in. So we can talk about those intelligences, and I'm going to mix up intelligences, skills, competencies interchangeably. I know that we might be, if I was talking with my PhD students, I'd say you'd have to have a little bit more conceptual clarity and distinction, but for the purposes of this, I'll just mix it up. So we often talk about the set of different intelligences. So there's rational intelligence, which we talk about as IQ. There's existential, ethical, spiritual intelligence. People have different names for it. And there's social, emotional intelligences. And where I think we're at is, I think we're really good at the rational intelligence skills, the STEM skills, because that's our bread and butter. That's what we teach, that's what we do with our technology work. Although I did see that a paper being presented at the conference that talks about technical excellence and what that means in projects, and that obviously even still in the rational intelligence area, this can be debated and discussed. And I see a lot of the initiatives that we just looked at around ethics and values and the manifestos and that as starting to connect to some of the, or at least provide the groundwork for some of the more sort of existential sort of skills, because they are about values and meaning and critically reflecting on the greater good. But I don't see us really taking the social emotional skills seriously enough yet. So what are these skills? Just for the exercise, I'm going to use this graphic from CASEL, which is an organisation that does a lot of work teaching kids in schools to develop these skills. And they talk about responsible decision-making as one block of their model. And you can see how that connects to our values and ethics stuff. And that's respectful choices, analysis, problem solving, being a reflective practitioner as well in supporting the learning. And the core of social emotion skills are often recognised in terms of the self and the social, the relationship stuff. So in the self set of skills, there's an important part about just self-awareness, being able to recognise your own emotions, knowing what your own values are, your strengths, what your limits are. And it connects to things like self-efficacy and initiative and things like that. And then there's the self-management set of skills, which are about how we deal with stress, how we might deal with uncertainty, being adaptable, having a work ethic, being able to time manage and so on, being able to set goals and being able to achieve them, and the resilience that we might, and I'm sure that everyone has demonstrated in enormous ways over this last year and a half in responding to the recent situation with COVID. And then there's a bunch of skills that connect more to how we interact with others. And that's about, again, in the awareness and more of the management. And the awareness skills, it's more of the empathy, perspective taking, really appreciating diversity and knowing how to work with it in a respectful way and so on. And in the management side, or the relationship skills, the communication skills, listening skills, how we deal with conflict, and how we develop positive relationships, especially in teamwork and collaboration that we're dealing with. Now, me naming these skills is nothing new, and you will have heard about them as well over the years. And what's interesting, though, is the increasing prominence they're getting within the technology sector and in industry sector. So this is a report from the World Economic Forum where they try to project what are the skills needed to thrive in some next period. And you'll see here, I know there's a lot to read there, so you may just want to focus on the 2022 set of skills. The red dots, there are only 2 of those skills in that list that really reflect some of the rational IQ type skills, the technology design and programming, and systems analysis and evaluation. All the rest would find their home in our social emotional skills wheel. And in particular, I draw attention to leadership and social influence and emotional intelligence there as really core skills. And you can see other skills around, that critical thinking and problem solving and so on, complex problem solving. IBM, a 2019 report that looks at what do they think, in their review, what do they think are going to be the most important skills for the workforce. And again, what you can see here is all of the skills in blue reflect the social emotional skills that we've just talked about. And so, we have willingness to be flexible, agile, adaptable, time management, working effectively in team environments, communicating, the capacity for innovation, creativity, ethics, integrity. And that their skills in grey reflect more core technical skills. And what's interesting is all of those blue skills, except for ability to communicate, that just went down from 3 to 4, have jumped up in importance. Google had an internal project called Project Oxygen, where they were looking at what made their best teams work well. And they then looked at what were the qualities of a great leader, manager of those really good teams. And again, just look here, that only 2 of those are vaguely more technical. Well, one is basically technical skills. Number 8, it has key technical skills. Number 4, about being productive and results oriented. But all the rest of the skills are about people oriented, human skills, about communication, about empowering your team, being a good communicator, listening, collaborating, and so on. Atlasian, another software development company that actually does products for software development, so they're software development tools that you may be familiar with. They take teamwork really seriously, and they talk on their webpage about, we found that hiring great talent and using the right tools wasn't enough, necessary but not sufficient. How we work together as a team made the difference. And this is also reflected in another research project internal to Google, Project Aristotle, where they looked at what were their best teams, and their best teams were not the team with all of the top tech stars. It was how the teams worked together. And they identified things like psychological safety as a really top important thing. And that involves things around empathy and open communication and a safe space to make mistakes and admit and learn. And they also identified other things around dependability, which is some of that those self-management skills and getting things done, as well as having clear roles, like how they worked in teams, and also about meaning and impact of their work. And Atlasian also, here you can see in this graphic with the figures, presented similar figures, with 60% more likely to achieve faster, 80% report increase in well-being. So there's lots of positive work outcomes. So how might we go about taking the development of these critical enabling human competencies more seriously? I have two starting points. One is, let's stop calling them soft skills. I don't know about your place, but often in our place, they're just, there may be a soft skills module and students pick one when they want an easy option for a semester. But they're anything but soft skills. They're the hard skills. Other people have variously called them power skills, human skills. IBM called them behavioural skills. And they're critical lifelong skills. And if we take the lifelong seriously, then we also need to recognise that they're skills that can be learnt. We're not necessarily born with them. And they need to be developed through real-world experience and being reflective practitioners. And I think it's time we stopped having them as little standalone, perceived as easy courses that just fill up a degree program. And we actually think about how we might embed them across all of the curricula, in all of our projects, in all of our organisations and institutions. If we take this seriously, we have to think about, how do we take teamwork skills seriously? And I don't know about you, but in many of my courses, I have the students working in group projects. And I've always had as a learning outcome for the course that, that they learn to work together and to collaborate. But I realised that I'd never actually scaffolded that work, that project work, really very well. And I'd never helped them learn how to work together in a team. So I've started in any of my courses where we do group projects, one of the first activities the team does is they work through this worksheet, and there's a link to it from my homepage through the HCI group website, and that you can take and reuse as you wish. And I've borrowed and drawn on resources that lots of companies provide. And it has some broad steps in it. So the first step is I get them to stop and think about what are their own skills and strengths and preferred ways of working. So that self-awareness piece. And for this, I do something that I've adapted from Atlasian's My User Manual. Atlasian have a great set of team building tools and resources that they freely share on their website. Google also have lots of great resources that they share for teams. So once they get a sense of what their own skills in that are, I get them to then come together and discuss it as a team to look at, get to know one another, identify what people's preferred team roles are, and best matching who's best to play different roles in the team. So that's social awareness. And here we can also point them to things like Clifton's Strengths, which have more project-oriented strengths sets that you can look at. And then there's the job of how do you pull it together? So how will you actually fit together as a team? So designing the team, and how will you actually work together and communicate and resolve conflicts? And this gets developed in a team charter, and then they're encouraged, and this is why I actually need to better support them moving forward. One of my points of reflection from the last year in doing this, in actually revisiting this at regular checkpoints to reflect on it and reiterate. So taking teamwork seriously. And taking teamwork seriously also means taking difference seriously, because we're talking about increasingly diverse teams. And we know from the research, and I'm sure many of us from our own experiences, that diverse teams actually can be hard work because you're diverse, because there's usually more tension, because there is normally more work needing to be put in, even if it's not so much conflict and tension, but just trying to work out where each other's coming from. But the research consistently says diverse teams perform better. If in organisations have better financial outcomes, in other domains they're more innovative and creative and so on. But how do we take differences and diversity seriously? So one of the things I'd love to get us to do is to often think beyond the tick box of gender, race, ethnicity, etc., which are all critically important. And this is an and there are lots of other dimensions of difference that can matter for our projects and that can generate some of the tensions that we need to work through, and where we may need different perspectives coming in, and whether that's from different disciplinary perspectives and their methods and theories and that they bring, or your background experience, or just different personal ways of thinking or individual differences. And again, I noticed a paper in the conference proceedings about personality traits and productivity and what's that relationship. And just a really funny example of this was the first iOS video uploader for a mobile phone from YouTube. They found that X%, I think it was about 15% of videos that got uploaded were upside down. And it was because they didn't have any left-handed people in the development team. And so people who were left-handed had trouble using the video uploader. So broaden our understanding of what's the diversity that we need to engage with, and then think about how do we actually it's not enough just to have different voices, different perspectives, but what are our processes to include them, to give them a voice, to hear them, and to work out how to integrate perspectives. And that takes really skillful human practices around deep listening and really seeking to understand what different contributions might be and how to value them. It's about negotiating, some of the tensions and ways of working, and working out how to constructively work together despite or enabled by these differences, which are so critical for creativity and innovation. I want to argue that in all of this, we also need to be taking well-being seriously. There is so much literature that talks about the levels of stress increasing at all levels within academia, from professorial level down to our undergraduate students. Research that talks about academics having higher levels of burnout than the general population. And we know a lot of the reasons for that around excessive work demands and performance criteria and managerial culture and so on. The challenges that these create for balancing family life. And we're also seeing increasing number of research studies and rising rates of mental health issues among our student populations. And this was all before COVID. And this is so much more of an issue and so much more serious now. And this will be a hidden cost if we don't work out how to take well-being more seriously within our software development practices, within our faculties and institutions. And well-being isn't a nice to have or a softy thing either. A lovely quote from a University of Berkeley study that talks about, far from diverting attention from academic and research priorities, well-being is a critical enabling condition for academic success. The science is clear. Balanced, happy people are more productive, more creative, more collaborative, better at long-term goal pursuit, more likely to find employment, and more physically and psychologically resilient. Now, we're scientists and we should be following evidence-based practices, and this is where the science is. It's saying, take well-being seriously. And it was lovely to see Austin Rayner pointed me to this new course being developed by Laurie Williams, who you may well know as a professor at North Carolina State University, software engineer, where she's developed a course called The Vibrant Academic that is explicitly trying to address some of these concerns. I know that it's some of the issues that motivated me to do the Changing Academic Life podcast series as well, so that we could actually share experiences and ideas for how we can do better at this. And we also run courses and programs about helping people craft their good academic life and not buy into the structures and rhetoric that putting the pressures on them. But it's no good putting all of the pressure on individuals to look after their own well-being either, though. If we don't have the policies and structures and processes in place to actually create a good environment in which people can learn and thrive and do their best work. And we have a lot of work to do at this infrastructural level and a lot of reflection to do, and whether that's within our own research groups and how we engage there, whether it's in our faculties, at our national levels, within our international peer communities. How well do our policies and processes and so on support good well-being, good life? And part of taking culture seriously is also thinking about training up leaders. When I was a nurse, you would be a nurse one day and then they might ask you to be in charge of a ward the next day, which is an entirely different skill set than actually caring for patients with no training. And it's exactly the same in academia, isn't it? We may move into more management leadership positions and they may be more formal or more informal, but we never have the training to look at how do we lead ourselves and how can we lead others in a really good way that brings out the best in people, that where we can be contributors to creating those environments that people can thrive in. And this is, again, some of the motivation for the course being offered through Informatics Europe with Austin Rayner around academic leadership. And I think they're really important skills that we all need to develop. So just in wrapping up, where technology is now, it's not just about the code. It's not just a technical challenge, a software challenge. It's a much more complex human societal challenge. And while technical and discipline competencies are so critically important to getting to good solutions, we need the and. We do need to engage more deeply with the ethics and the values and the critical thinking and the interdisciplinarity and move them beyond the guidelines into practice. And to do all that, we need to develop our critical human competencies to put all this to work. And it's work to do. And this is how I think we're going to equip our software engineers for the future. So I just want to leave you with the questions about what might this all mean for you and developing your own skills? What can you do to help your students develop skills? How might it influence or change how you collaborate or even who you collaborate with? And what can you do to help change the culture and the processes to have a more enabling environment? So thank you and look forward to discussions.